Alright, so here's an example of run-then encoding. Let's recall that run-then encoding works on the principle of repetition in the data. Okay, so it works by replacing repeated blocks of data. Alright, so it works by replacing repeated blocks of data. Right, so let's take our first example over here. In this first example, we have this is supposed to be representing a picture, okay, but this is a highly simplified version of a bitmap image. Okay, it just has zeros and ones, and each time there's a one over here that represents a white color, and each time there's a zero over here, this represents a black color. Okay, so this is supposed to be representing an image. Okay, the first thing we are going to do is, first of all, for computer, it's just a series of bits, right? So it will represent this image in terms of like bits like this. Okay, so the first block is written like this: 0011. Okay, so 0011, and then the second row, okay, which is 1011, and then the third row, which is 1011, right? And then the last row, which is 0000. So for the computer, computer does not care about how this these bits are represented in the image. It does when it has to construct the image, but for when these bits are going to be stored in the computer, they are going to be sent as these series of bits. Okay, now if we get those bits written down like this, so again you can check this is the exact same bits that we have over here. Okay, so these zeros are here, then there is 1 1, so there is 1 1, and then there is another one in the next row, so that's this one over here. Okay, so please pause and do make sure that you do understand how this same image is being represented as a series of bits over here. Okay, now the next thing is you have to see where there's a repetition, whether a repetition of zeros or ones, and then record that. Okay, so you have 2 times zeros, and then there is, actually let me use a different color for one, then there is 1 3 times, then there is a 0, and then there is a 1 3 times, then there is a 0 again, then there is a 1 2 times, and then there is a 0 4 times, right? Now how many bits, how many digits do we have for this series of bits over here, series of data points over here? There's going to be a total of 16 bits, right? So there's a total of 16 digits, let's say. Okay, but if we just record the repetition, which is, let's say there are 2 zeros, right? So we will write it down like this: 2 0. All right, and then there is a 3 1, so we will write on 3 and then 1. Okay, then there is 1 0, so there's 1 and 0. Okay, then this is over here, this is over here, then there is 3 1s, right? So 3 and then 1, then again there is a 1 0, so 1 0 over here, then there are 2 1s, so 2 1s like this, and then there are 4 zeros, so 4 and 0. So every time what are we doing? We're just recording the repetition. Okay, and then after repetition we are writing down the digit itself. Okay, all right, so there is a repetition and then there is a digit, repetition 2, and then the digit 0. There are 2 zeros. Okay, then there are 3 1s, so 3 and then 1. Okay, and there is a 1 0, so there's 1 and then a 0. Okay, so you have to record the repetition and then the digit. That's it. That's how simple the process over here is. Okay, now if you count the number of digits now, it is going to be 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So there's a total of 14 digits now being used to represent the same image, right? Because you know how many repetitions there are, and these repetitions are in order, right? So you can actually take this entire block of data and use that to construct the original number of bits, right? I mean, if I tell you there are two zeros, you will write down 0 0, and then three ones, you will write down 1 1 1, then 1 0, so that's 0, and three ones, so 1 1 1, and then 1 0, so that's 0, then two ones, so that's 1 and 1, and then 4 0, so 0 0 0 0. That's how you can get this compressed file, which is composed of 14 digits, and construct the original file itself. Okay, so that's the key idea behind run length encoding. Okay, go back and try to do this by yourself. Okay, now in a second example, again we will try to first of all take out these bits and try to represent them as a stream of bits over here. I've already done that, so I'll just copy paste that, those ones and zeros over here like this. Okay, so this is just another example of the same thing. Right, again you can check, pause the video and check this yourself. There are 1 2 3 4 5 6 and then 7 8. So 1 2 3 4 5 6 and then 7 8, all these ones over here. Then there are 4 zeros, so 4 zeros. So and all of this is in sequence. Okay, so using the same idea, which is repetition and then repetition and then the digit itself, we will again try to compress it using run length encoding. Okay, so the first thing we're going to do is of course mark out the repeated bits. So there is how many? 8 ones, right? So we write down 8 1, and then there is 4 zeros, right? So 4 and then a 0, right? Then there is 2 ones, right? So there is 2 and a 1. Then there is 1 0, and then again 1 2 3 4 5 ones. So 1 0 and then 5 ones. Okay, then there is gonna be 4 zeros, so 4 and a 0. Then there is going to be 2 ones, right? Again, by using the same idea, I'm going to complete this now. Alright, so there is again 1 0, and then after that there are 1 2 3 4 5 ones. Then there is 1 0, and then there are 3 ones. Again, if we try to count the number of bits that there are in the original set of data, there was a total of 36 digits over here, right? So 36 digits would be used to represent this image. But after recording the repetition and then the digit itself, let's see how many digits we have now. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22, just 22, right? So we have a total of 22 digits being used to represent that same image. And again, if I were to provide you with all of this data, you can actually construct this original set of digits, right, which then can be used to represent this image if they are put into order, right? Now these both examples were from images. Now let's also look at an example where we are using text instead of images. Okay, again the idea is to record the number of repetitions. Okay, now again this time we have letters instead of ones and zeros, but these are also again just digits, right? So we will mark them for repetition. Okay, and again we have first of all 5 A's, right? So for that we'll just record the 5 and then the binary code for small a, right? The binary code for small a is 97, because remember, I mean, actually let's just keep it simple first. So there's going to be 5a, and there's going to be 4b, and then there is going to be 4a, and then there is going to be 4c, right? But when it comes to letters, there's another thing that you need to do. You need not to keep the letters as themselves, but rather convert them into their binary equivalent. Okay, sorry, denary equivalent using ASCII. Okay, so in ASCII, how is a represented? A is represented using 97, right? Then how is b represented? B is represented using 98, right? And then how is a represented again? Using 97. And then how is c represented? Using 99. Okay, so this will be our answer in that case. Okay, now there is although one little problem over here, which is when we read this 5 or this 97 or this 4 or this 98, how do we know which number is representing the repetition and which number is representing the digit, right? One way around it is to just decide that the first digit is always repetition and the next one is the digit, okay, which is the denary code for small a. But there's another addition that we can do over here, which is to use a specific number, let's say 255, to differentiate between each set of repetition number and its digit. Okay, so after every, let's say 597, I will write down 255. Again, after 498, I will again write down 255. Okay, again 497 and then 255. Okay, and then 499, and that's it. Okay, so again, in between each block where there is the first number is representing the repetition and the second number is representing the digit itself, we have inserted this 255 just to separate them out completely. Okay, now using the same idea, try to write down the answer for this one. Okay,